Alright. First thing, on number 5, can we get the bases the same? No, you cannot. You cannot get the bases the same. Remember, turn whichever way you have to be able to see the board, okay? Turn whichever way you have to see the board. Alright, on number 5. So if I can't get the bases the same, then what I'm going to do? Take the what of both sides? Log. Watch how I do this. These right here take kind of it takes a little bit longer to do that. Alright, so I took the log of both sides. Now, can I just divide both sides by something here? No, what you got to do is actually get the decimal here, guys, on both sides and distribute that decimal to both things on that side, okay? This is different from these up here where you had that one log and you just divided both sides by it to get rid of it on this side. Here you're going to actually have to find the decimal and distribute. So I'm going to find log of 4. So it's going to be 3x minus 1 times 0.602 equals 2 minus x log of 3, which is 0.477. Now I'm going to distribute both of those to the...
Did you find log of 3 right there?
I found log of 4 right here and log of 3 right there. So now I'm going to say 0.602 times 3, which is 1.806x minus 0.602. Now distribute that. 0.477 times 2. And then you just do the algebra, solve the equation, move that over. Then divide by that 2.283. X equals 0.682. Let's do number 6. Are there any questions number 5? 0.682. Alright, let's look at number 6. I'm going to write it on here so I have plenty of room. Can we get 6 and 5 to be the same basis? No. So, I'm going to bring this down, the 2x plus 4, and I'm going to take the log of both sides. Bring that x plus 1 down, take the log of 5. I got to find what log 6 is. .778. Log 5. 0.699. and then I would distribute those numbers to everything in the parentheses. Once you do that, you just solve it like a normal equation. You can do you can do it all in your calculator. I'm gonna move this over here. That's gonna be a minus 0.699. Good morning.
Morning.
So far, while you're getting caught up, let's recap. We've looked at exponential equations where the first thing you do is get the base side. Those are the easy ones. Then you had like stuff like 3 raised to something equals 17. Well, you can't get those base things, so you took the log of both sides. But now you have these, where you have these things on both sides, to take a log and then distribute that decimal. Those are the 3 types we looked at so far. Are there any questions on what we've done so far? Because they're going to be mixed up, and you're going to ask yourself, okay, what's my plan of attack here? What do I do on this one? All right. I want you to look at number 9. Number 7 and 8 is done the same way. We're not doing all those. Let's look at number 9.
What was x equal to 6?
Negative 2.816. Negative 2.816. What does number 9 look like to you? It looks like a factoring problem, don't it? You remember the problem like x squared plus a coefficient of 1? That is really what this is, okay? But it's involving e's, and I'm going to teach you how to attack this, okay? Use a process called use substitution. Use substitution. All right? Let u equal this middle term right here. I mean the e to the x. Let u represent that. And I'm going to rewrite this using, if e to the x is represented by u, this will be u squared plus 6u minus 16. Let u represent that middle term every time. When it looks like this looks like it can be easier factored, okay? Because that's what you got to do on this problem. It's got to multiply to give you negative 16, add to give you 6. What 2 numbers do that? Positive 8 and what? Do you see that? I'm going to stop right there. Is there anything confusing you that what I've done so far? I let u be that middle term. I wrote it with u's. Just misread. I like an n. I don't care. You can use an n or x, whatever. I just use u because in calculus you're going to see something called u substitution. Now, once you get to this point, what did you let u be? What was u? E to the what? You go back and put that in for the u. And now you have 2 equations to solve. In all these problems, guys, that we've done, the exponential part's been by itself, isolated. Like on this one right here. Oh, did we do number 4 on Friday? Ooh, we might need to go back and do number 4. All right, we'll go back to 4. But you want your exponential part to be isolated. So what do I need to move over first? It becomes a negative 8. Now, can I get the bases to be the same? So what I'm going to do to both sides? Take the natural log of both sides. What's the natural log of E equal to? 1. I don't have to worry about that. Now my next question is, I want you to type in natural log of negative 8 in your calculator. Type in natural log of negative 8. What do you get? Error. Are logarithms defined for negative numbers? No. So if you get to this point and you see natural log of some negative number, you can stop because this is no solution on this side, okay? No solution. Logarithms are not defined for negative values. All right, now let's move it over here. Take the natural log. Can we find the natural log of 2? Yes. 0.693 is your only answer for that particular problem. Let's get back to number 4. We're going to come back to one like this in just a minute. Let's go to number 4. I should have done 4. On number 4, you have 8e to the 2x equals 20. You want your exponential part to be by itself. So the first thing you need to do in this particular problem is divide both sides by what? 8. Divide both sides by 8. And you get 2.5. Now, the exponential part is by itself, isolated. Can you get both sides to be the same base? So you have to use what to help you solve it? Natural log. So I'm going to bring the 2x down. Take the natural log of both sides. What you doing to one side, you doing to the other. Natural log of e is 1, so we don't have to worry about that. So you simply can do natural log of 2.5 in your calculator and then divide it by 2. That's 0.458 is your answer. Are there any questions on number 4? Alright, let's go back and do number 10 now. Alright, that's back to looking like a factoring one. What do you think this needs to be set equal to? 0. So I need to move the 8 over. I need to move the 8 over. So I have e to the 2x plus 2e to the x minus 8 equals 0. I'm going to use my process of u substitution. What will I let u equal in this situation? E to the x. That middle term, e to the x. E to the x. And then I go back, this is going to be u squared, because it's e to 2x, u is e to the x. So if it's 2x, it'll be u squared, plus 2u minus 8 equals 0. It's got to multiply to give me negative 8, add to give me 2. What do values do that? 4 and what? Now once you get to that, I can go back in there and plug e to the x plus 4 equals 0. E to the x minus 2 equals 0. Here I move the 4 over, it becomes a negative 4. Could you really stop right there? Yes. You're not going to be able to solve that. e to the x equals 2. I cannot get the bases to be the same, so I'm going to take the natural log of both sides. Natural log of e is equal to 1. So x equals the natural log of 2, which is 0.693 would be my answer. We're going to do one more of these. Let's look at number 11. Number 11. That's supposed to be an x, not an s. 4x plus 8e to the 2x equals 5. Oh. That is a factoring one, but here the coefficient's greater than what? 1. So you're going to have to do bust them up, AC hard, or slide and divide. One of the three, whichever way you were taught. So I'm going to move the 5 over. What am I going to let u equal here? E to the 2x. It's whatever is sitting there, guys. Whatever. I know in the other ones is e to the x, but it's whatever's sitting there. Bless you. Now I'm going to write this with 4u squared plus 8u minus 5 equals 0. So it's always going to be u squared and u there. If you let u be whatever's in the middle right here, that will be u, and that's always going to be u squared. Now, I do bust them up and AC hard. Do whatever method you learn. It's got to multiply, give me negative 20, add to give me 8. That's positive 10 and negative 2. Now I'm going to go back and put my e to 2x in for my u, so that's be 2 e to the 2x plus 5 equals 0. 2 e to the 2x minus 1 equals 0. Take a moment. Make sure you understand how I got to that point before we finish solving it. Alright, now, when you're solving this exponential, you want to get your exponential part by itself. So I need to move the what over? 5 and then divide by what? 2 before I even start with that. So I'm going to move the 5 over, divide by 2. You can do all that in your head. That's going to be negative 5 divided by 2. That equals negative 2.5. Now, guys, are you going to be able to take the natural log of negative 2.5? So do you have to finish working that? No. Here, I'm going to move what over? 1 and then divide it by 2. So I'm dealing, that's 0.5, isn't it? Now, can I get those bases to be the same? No. So I'm going to use natural log. My power rule allows me to bring that 2x down, take the natural log of both sides. Natural log of E is equal to what? 1. Do I have to worry about that? No. So you just find natural log of 0.5 and divide it by what? 2. And I get negative 0.347. You said, Mr. Esther, when it comes to these decimals, what if mine's a little off? I'm going to look at your paper and look at what you got. If he computes out to how you had it, I'm going to give you credit for that, okay? Because it depends on what point part, where you round it, what part in your problem. Is everybody good with that? So far, we talked about 3 types. The first type, you always try to get the what the same? Basis. Next, if you can't get the basis the same, you're going to take the what of both sides? The log, or natural log. And then here, using U substitution. That's the types we're going to talk about. Is everybody good? Okay. So I just want to preview what we're doing tomorrow. So turn to page 9. We're just going to do one of these. Preview. Pass that, Jack. I'm passing my work back here, okay, buddy? All right. You just keep it right now. You're good.
No, I just needed that one.
Oh, okay. Pass it back up then. Okay. Tomorrow we're doing logarithmic equations. If it's in logarithmic, what you think you're going to do to solve it? Put it in what? Exponential. So watch this. 2 raised to what? What's 2 cubed? That's your answer. So if it's in logarithmic, you're going to put it exponential. 2 cubed equals that. And I get 17. How about this? It's in what form, guys? Logarithmic. So you're going to put it in what? 3 to the third is 27. And negative 25 would be my answer. So that's what we're going to start doing tomorrow. It gets a little bit more complicated than that, but just knowing that if it's in log, you're going to use exponential somewhere, okay? Tonight you have 8 problems, and it practices exponential on page 18 as you go through. Everybody good? And then tomorrow we're going to do logarithmic, and on Wednesday and Thursday, we're just going to put them together to make sure you know, okay, what type of problem is this? This is what I can do with this. Here's this guy. Just building that confidence. That's all we're doing this week is these equations. Yes, baby. Thank you. Y'all have a good one.